Now you understand set is the collection of well-defined objects. Okay. What is the exact meaning of well-defined objects? If I ask you the number of intelligent students of your class, you cannot form a set because mathematically that intelligence is not properly defined. So if I say the number of intelligent students of your class, that will not be forming a set. But if I ask you the number of students, those who have got 90 or more than 90% in mathematics of your class, if I ask you, then perfectly you can form a set of the students. So the collection of well-defined objects is said to be a set. The number of poor students of your class, if I say, then also you cannot make a set that poor and intelligence and all these are adjectives that cannot be mathematically defined. Understand that. So if a definition, or whatever the statement is given, it should be mathematically valid, then only it forms a set. So that is the basic definition of set. And similarly, if I say the rich people of Kuwait, if I ask you, the rich people of Kuwait, if I ask you, Maurya, then that will not form a set because that richness I have to define. That richness I have to define like this. The number of rich people of your country, Kuwait, those who are holding, $10,000 million, if I say, then you can list it out, isn't it? You can list it out. But if I say rich, if I say poor, you cannot form a set. This is what you have to understand. So this is very easy topic and follow it carefully. Similarly, how to represent the sets. What are the denotion or what is the notation we use to represent a set? Generally, all the capital letters we use to represent a set. And these are frequently used symbols to denote the sets. So n is the set of natural numbers and z is the set of all integers. So the set of all natural numbers, it is nothing but 1, 2, 3, 4, so on. This is set of natural numbers. And set of integers, you can see, it is all the negative integers and all the positive integers, they form an integers. All rational numbers, the set of real numbers, the set of positive numbers, the set of positive rational numbers, and r plus the set of positive real numbers and all. So these notations, I hope you know. Do you know or not? You tell me, please, both of you.
Yes, sir.
Chaitanya, you heard also respond, please.
Yes, sir.
So these notations, whenever these symbols are used, you must be in a position to understand the notations. And this is also easy. You have used this in your lower classes also. So now, what is that to be understood with regards to the number system? That is, if you take the numbers, among all the numbers, understand the complex numbers is the mother set and the real numbers is a set which is contained in the complex number set. And from the real numbers, you will have the rational numbers. And from the rational numbers, you will have the irrational numbers. So what is that to be understood in this case? You have to understand that the complex numbers, I'll put the reverse arrow for this. This is what I mean to say, this is complex number set. But before that, you must be knowing what is a complex number set. The complex number set, you will have a topic further on complex numbers, quadratic equations. You'll have a special topic on that one. We will be seeing that. Now, this is the rational number set. And this is Q complement. This is irrational number set. I'm writing only the notations there. Just understand. So what is to be understood? This rational and irrational numbers are, these rational and irrational numbers are contained in the real numbers. So rational and irrational numbers are part of real numbers only. Now, these rational numbers will be again containing all the integers. All the integers, please. And these integers will be containing the negative integers and again positive integers. And these positive integers again containing, I did not get answer class. So similarly, if you let me write this so that you will have more clarity about this. And with which letter we represent the integers, please? Z or I? Z or I. You have learned all this in your lower classes itself. Integers represented by Z or I. Now, this is containing I minus or Z minus. And this is Z plus. And of course, this we need not have to write them separately. You will be understanding integers and positive integers and negative integers. I'm eliminating that, but understand in this integers itself, you will have the natural numbers and you will have the whole numbers. Natural numbers and whole numbers. Okay, so this is whole numbers. This is natural numbers. So this is what you know already revised. This is revised now, just for you to make sure of the alphabets that are used to denote different number systems. And this is not frequently used. Which one? Irrational numbers. The symbol for irrational numbers is Q complement. You will be understanding now. Now in set theory, what is the meaning of Q complement? Do any one of you know complement, please? Q complement. Any one of you? Either Maurya, Chaitanya. Do you know the meaning of
sir, not the term, like not Q.
Not Q. Okay. Chaitanya, it is not Q means non-rational numbers. Non-rational numbers. Power C means not rational. Power C, if you write, or dash also, we will make use of it. You understand that? Okay. Now, so these are different notations we make use of. A set is a well-defined collection of objects, just now I said, and we will not be insisting on this more. And now, how a set can be denoted? It is denoted in two different forms: roster or tabular form, or set builder form. The roster or tabular form or set builder form. So roster form is just like writing all the listing out all the elements. If I say the vowels of English language, then simply if you list it out as A, E, I, O, U, this is simply you can say that it is roster form or tabular form. It is tabulated like that. Now, set builder form mostly used, please understand set builder form, how to write this. X is as, this colon mark is to be read as is as. X is as, X such that X is equal to, or simply X is as, you can say X is equal to oval of English language. Okay. So these are the two different forms you must understand in case of the set theory. And in any of these two forms, the sets will be denoted. Okay. Now, generally, they are denoted in the flower brackets. The flower brackets represents always the set notation. Set notation. Understand it, please. Okay. Now, these are all. We are not going to waste much time on this one. If you see the examples, you will understand that. But let me jump onto the exercise directly, so that you will also be comfortable. Okay, because in the beginning all these are very easy. Let me start with Maurya. Come on, read the first one and tell me first three you answer, Maurya. Next three Chaitanya will be asked. How many are there? 7 are there. Come on, answer first three, please.
The collection of all months of a year beginning with the letter J. That's January, June, and July.
Now, what is the question, please?
Oh, which of the following are sets? Sorry, sir. So the first one is a set.
Okay.
The second one cannot be a set because he didn't specify what kind of talent is needed.
Okay.
The third one is also not a set.
Good.
So should I?
Fourth one also.
Fourth one is a set, sir.
The fifth one is a set, sir. The sixth one is also a set, sir.
Very good.
The seventh one is not a set.
No, it can be, but we generally, there are two types of sets: finite sets, infinite sets. This is an infinite set. The collection of all even integers means the integers that are divisible by 2, no? 2 are all even integers. So we can write it as -4, -2, 0, 2, 4, 6, forms a set only.
Yes, sir.
But you cannot write them as a finite number, Chaitanya. Your confusion is quite reasonable. Your confusion is quite reasonable. You may be thinking that, like the previous questions, you cannot write a finite number of elements, but we have to write an uncountable. That's countable only, but finitely countable, we can say. Infinite numbers are different. We will be coming across such type of things. So the collection of all even integers is also a
Set.
set. Now,
The eighth one is a set, sir.
just a moment. Let me open it. The collection of questions in this chapter. Yeah.
It is a set, sir.
Okay.
And the ninth one is also a set.
Think.
It cannot be a set, sir, because uh, we don't know what kind of animals are dwell in this world.
Dangerous means you cannot define that because
Yes, sir.
dangerous means how much dangerous it is. How much dangerous it is, we don't know. So that's not a set. Common. Second one, Maurya.
Yes, sir. So what is that symbol?
Yeah, I'll come to you for that. Just a moment. Now this is a content I used to explain the objectives, and this is the definition of the set. Of course, I'll show you the different notations now. This is just now I explained the roster method, listing method, and this is set builder form or rule method. Set builder form or rule method, and now these are the symbols. Yeah. See, both of you, please. This one. This symbol is used for implies one statement, another statement. This is the link, implies. This symbol just now you asked belongs to. And this symbol, you will have subset of B. What is subset of B? Again, we will see that. We will see that. We will come across that. Then we'll be discussing that. This is called implies and implied by. You did theorems in your lower classes, 9th and 10th classes, the plane geometry theorems. In those theorems, generally, if you have a theorem, you will have converse of the theorem also, isn't it? Respond, please, both
Yes,
of you.
sir.
Yes, sir.
Converse of the theorem. Converse of the theorem means if the theorem is proved from top to bottom, that is from the beginning till the ending, then if you prove the theorem again from the end to the beginning in the reverse process, that is converse, then that is called both sides it is true. That is called both sides it is true, and hence we call it as implies and implied by. Implies and implied by means from left to right it is true, from right to left it is true, from top to bottom it is true, from bottom to top also it is true. That is called implies and implied by, or if and only if. This is also same. Both are same. And it is, you can see it exactly does not belong to. Whatever belongs to symbol is there. If you put a cross mark for that, if you cross it like this, then it is does not belong to. And ST is also used, which is used for such that. And these are the symbols you must know. For every, how is it written? V symbol with a horizontal line in between. V symbol with a horizontal line in between. This is called for every. And the last one is exactly the mirror image of E. Mirror image of E. This is for there exists. You remember this mainly. What are they? This one is a symbol used for belongs to. And this one implies is frequently used. And this is subset. Anyway, we'll be learning that. It is implies and implied by. And it is does not belong to. It is such that. It is for every. This is there exists. Remember that. There exists. Okay. If you want to store it, take a screenshot of it, please. Take a screenshot of it, both of you. Store it in a comfortable folder.
Yes, sir.
Yeah. Now, see this one. Now read that, Maurya.
Let A equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol for belongs to or does not belong to in the blank spaces. 5 belongs to A, 8 does not belong to A, 0 does not belong to A. So should I finish it?
Yeah, finish it.
4 belongs to A, 2 belongs to A, 10 does not belong to A.
Yeah, Chetu, you're comfortable with this, no?
Yes, sir.
It's simple only. Come on, you come to third one, Chaitanya.
Yes, sir. Write the following sets in roster form.
Yeah.
A equal to X is
How to read this, I am explaining that. A is equal to set of X is as or X such that also you can say.
yes,
X
sir.
is as, I write it here. X is as, one form of reading it. X such that. Whatever is comfortable, you can read that. Come on, read that.
Yes, sir. A equal to set of X such that X is an integral and 3 less than
X is
X.
an integer.
I'm sorry, sir. X is an integer and 3 less than X less than 7.
See properly? -3. -3.
Okay, sir. I'm sorry again.
Come on, tell me. Now you have to write it in the roster form. That is listing method. We can call it as listing method. Come on, list out all the integers between this.
Okay, sir. X equal to -2,
Good.
-1,
Yes.
0, 1, 2, 3, 4, 5, and 6.
That's it. Yeah, go to the next one, second one.
B equal to set of X such that X is a natural number less than 6. So X equal to 0. I'm sorry,
No,
I'm sorry, I'm sorry. 1, 2, 3, 4, 5, and 5.
that's it. Next.
C equal to set C equal to X such that X is a two-digit natural number such that the sum of its digit is 8.
Yes. I'll give you a hint. 17.
Yes, 17, 26, 20, 26, 30,
5.
35, 44,
Yeah.
50, 53,
Yeah.
62,
Okay.
71, 80.
80. So up to 80 you will have. Correct, no?
Yes, sir.
Yeah. All right, Maurya, go to fourth one. Maurya. Maurya, respond.
Yes, sir. I have to go somewhere, sir, please. Yeah, yes, sir.
Fourth one.
Fourth one, x is as x is a prime number which is a divisor of 60. Um, so 2,
Which is a divisor of 16, huh? Which
yes,
is
sir.
divisor of 60. Yeah.
Just
Okay. 2 is a prime number. Okay.
so even 3 is
Yes. Correct. 5
so
also.
5.
Yes.
So that's all that is when you can take 60 as
2, 3, 5. And what more?
3, sir. 3. Oh, 2, 3, 5. So that's all, right? When it comes to,
Yeah.
we can't get any more
Understand now.
prime numbers that are.
Understand. if you write the prime factors, no? What are the prime factors? 15 into 4. So 2 square into 3 into 5.
3 into 5.
So 2, 3, 5, that's all.
Yes, sir, that's also.
Yeah, come on, tell me now the next one.
Uh, T. So the next one, right? So just T R I G O
Okay.
N M E
Now
T R
simply you
Y.
got to put a
Oh
comma
wait,
in between all.
R and T cannot repeat. T
Ah,
R and
yes,
G cannot repeat.
yes, yes, that's
So
all.
it's T R I G O N M E Y.
Chaitanya, you understand, whenever you are writing the listing, no, in the listing, the element should not be repeated.
Yes, sir.
TRIGON, M is also there,
E
E also there,
and Y.
Y, that's it. Yeah,
The last one, BETR.
that's it. Okay, is it clear, Chaitanya? We're moving to the next question.
Yes, sir.
Come on, tell me fourth one.
Write the following sets in the set builder form.
Yeah.
So there are two different kinds of brackets. What do they mean?
No, this is wrong. That is correct. Yeah, you tell me.
Yes, sir. The first set is x such that x is one of the first four multiples of 3.
Okay. You want to say like that. Okay. Now you can say like this. X is equal to 3n. Okay. X is equal to 3n, where n is equal to 1, 2, 3, 4. You can say like this also.
Yes, sir. For the second one, x such that x is equal to 2 power n, where n is equal to 1, 2, 3, 4, and 5.
Very good. X is such that where n is equal to 1, 2, 3, 4, 5. Huh?
Yes, sir.
Yeah. Then the second one done.
And for the third one, x such that x such that x equal to 5 power n, where n is equal to 1, 2, 3, and 4.
That's good. Yeah, come to the fourth one.
Yes, sir. X equal to, I'm sorry, x such that x equal to 2n, where n is equal to 1, 2, 3, and so on. How do I say?
That's good. You're right. You can simply mention it as n belongs to n.
Okay,
Here
sir.
the number notations are this. N belongs to n means any natural number, because and so on is there, no? 2, 4, 6, and so on is there. And
Yes, sir.
so on means it is a countably finite set. Countably finite set. That is why we
Yes.
write it as n belongs to n. That's it. Correct. You're right. Next.
Yes, sir. And for the fifth one, x such that x equal to n power 2, where n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
You can write even like this also. The
Yes.
other ways, different ways of notation. 1 is less than or equal to n is less than or equal to 10.
Yes, sir.
Or yeah.
Yes, sir.
1 is less than or equal to n is less than or equal to 10 means n is equal to 1 gives you first element 1, n is equal to 2 gives you second element 4, n is equal to 3 gives you third element 9, n is equal to 10 gives you last element 100. These are different types of questions written in the set builder form. Set builder form. Is it okay?
Yes, sir.
Now, come to fifth one, Maurya.
Yes, sir. List all the elements of the following sets.
Listing.
X is, sir.
Listing. Yeah.
Yes, sir. X is such that X is an odd natural number. So that's 1, 3, 5, 7,
And so on. That's it.
11, and so on.
Faster. Second one.
X is such that X is an integer, comma minus 1 by 2 less than X greater than 9 by 2.
Less than 9 by
Uh,
2.
yes, sir, that's all.
You
Less
said
than
that
X greater than
minus 1 by 2.
so,
Less
so,
than X.
greater than X less than 9 by 2. So that's 0,
Okay.
1 by 2, 1.
Integer. No, integer.
Oh, so
What is 9 by 2 value? You tell me what is the value 9.
3.5, 4.5.
4.5. Come on, tell me the integers up to 4.5.
So 1, 2, 3, 4.
That's it.
Oh wait, that's it, right, sir?
Yeah. Any doubt in this?
No, sir.
Come on, tell me third one.
X such that X is an integer, X square greater than or equal to
No,
4.
you are just
Less than.
Hmm. Yeah.
X. So that's 1. Yes, sir.
Okay.
Only 1, sir. 2. 1 and 2. 1 and 2. Less than or equal to.
Correct.
X such that X is a letter in the word loyal. LOYA.
That's it. Next one.
X such that X is a month of a year not having 31 days. Okay, so I might need some time for this. January. So February is there.
So you understand that now?
April. Yes, sir. Yes, I understood that, sir.
April is there and June is there
May, June.
and so on. Isn't it?
Yes, sir.
Yeah, finally. Sixth one.
Sixth one. X is to X such that X is a consonant in the English alphabet which precedes K. So that's after K. Okay, L, M, N.
Oh. Before K, no?
No, sir.
Succeeding means after.
Oh, yeah. Sorry, sir. Oh. A, no. B, C, D.
X is a consonant, okay.
Consonant, sir. B, C, D, E.
And so
No,
on.
wait. B,
Okay,
C, D. Yeah, and so on.
Come on, Chaitu. Come to sixth one.
Yes, sir. Do I read the question or do I answer it simply?
Yeah, you both.
Yes, sir. Match each of the set on the left in the roster form with the same set on the right described in set builder form.
Yeah.
So the first one I would match it with B, sir. Sorry, C.
1,
The
2,
second
3, 6. X is a natural number and divisor of 6. Very good.
the second one I would match it with A.
Prime number and a divisor of 6. Very good.
The third one I would match it with D.
Good.
And the fourth one is B.
Done. That's
Yes,
it.
sir.
That's the first exercise. Now let us move on to the next part of it. The empty set. Empty set means if a set is containing no elements is nothing but an empty set. So X is a student of class 12th presently studying in a school. Just understand what he gave. X is a student of class 11th presently studying in a school. We can go to the school and count the number of students presently studying in the class 11th in the school. Then the set A contains finite number of elements, of course. That is like your class. We now write another set B as follows. Just I'm reading it up. Not a prominent, no prominent explanation is needed for this one. This is very simple, which is containing no elements. So X is a student presently studying in both classes, 10th and 11th. How is it possible? So it is a null set. It is a null set. No such case exists. The student who is studying both 10th and 11th. That is said to be an empty set. Okay. Similarly, you can have your own example. Tell me an example for empty set, Maurya. Of your own, any case, not only school, any case you can take.
Okay.
Any case you take and give me an example for empty set. Or Chaitanya, you also.
Yes, sir, I'll try.
It's a little hard, sir, when you ask us to come up with it instantaneously. So
No problem. You take your own time, no problem. Number of times number of teams, rather I can say cricket teams, number of cricket teams participated in Olympics. Are there both of you?
yes, sir.
Yes, sir. Yes, sir.
Which set?
Null.
Null set or empty set, or it is also said to be void set. Null, empty, void. Okay. Like that, you can give any example which is not containing any elements, which is not. You want to say any example, Chaitanya?
Yes, sir.
Yeah.
The number of non-vegetarian dishes at a vegetarian dinner.
That is a good one.
You like non-vegetarian, I understand. You might have faced that situation, isn't it, Maurya? So that is why he gave.
Yes, sir.
That's good. Okay, like that it is. Now a set which does not contain any element is called an empty set or the null set or the void set. Okay, so algebraically, how do you understand this? Let us take an example. This is water. The good examples are given here. Let A is equal to X such that 1 is less than X less than 2. X is a natural number. What is a natural number lying in between 1 and 2? No natural number is present. Then A is an empty set because there is no natural number between 1 and 2. Similarly, next one. B is equal to X such that X square minus 2 is equal to 0 and X is a rational number. X square minus 2 equal to 0 means X square is equal to 2. X is equal to plus or minus root 2. Root 2 is not a rational number, and hence the number of elements will be 0 in that set, and hence it is a null set or void set or empty set. Next, C is equal to X such that X is an even prime number greater than 2, even prime number greater than 2. Then C is the empty set because 2 is only the even prime number. A very important point to be noted. Among all the prime numbers, only one even number is there, that is 2. So X such that X is an even prime number greater than 2. No even prime number is present in the number system except 2. Except 2. So that is why he said greater than 2. Okay. Now, next one. D is equal to X such that X square is equal to 4. X is an odd number. X square is equal to 4 means X equal to plus or minus 2. So D is the empty set because the equation X square equal to 4 is not satisfied by any odd value of X. If it is given that X square is equal to 4, X equal to plus or minus 2. Plus or minus 2 is even, so no odd number is present, and hence it is an empty set. Like that, you can have good number of examples. Even real life examples also you can have if you think. Okay. Next, finite and infinite sets. Simply in the name itself, we have the meaning of it. Finite means countable. Infinite means not countable. Countably finite. Countably infinite. Simple. The number of elements that are countable is finite. Not countable is infinite. A is equal to 1, 2, 3, 4, 5 is a countable set. B is equal to A to G, alphabets of English language, is a finite set. C is equal to men living presently in different parts of the world. It is mathematically, it's an infinite set. Okay, infinite set. Okay, so this is what, nothing more prominence is there for, because in the title itself you can understand the meaning of it. A set which is empty or consists of a definite number of elements is called finite, otherwise the set is called infinite. The examples: W be the set of days of the week, Monday to Sunday. S is the set of solutions of the equation x square minus 16 equal to 0. X is equal to plus or minus 4. Finite. G is the set of points on a line. Points on a line will be infinite. Like that it is. Okay. Now let us straight away move to the exercise if it is given, or otherwise let me explain you what are equal set. There are equal sets and equivalent sets. Both are not given. Let me take it from that objective part. Let me explain you that. These are the different symbols I explained. Null set, empty set we have seen, and I think if not all are given in your textbook, let us cover those concepts from the objectives which are required here. Singleton set, in the name itself, it is a singleton set. Okay. Till you get married, you are a singleton set, isn't it, Chetu? Are you singleton set or not?
Yes, sir.
And as far as I know, Maurya is also a singleton set.
Yes,
Maurya?
sir. Yes,
so
sir.
the set consisting of only one element is called singleton set. The set 5 is a singleton set. It is set of 5. Finite set, infinite set, just now we have seen. I don't want to extend it. Now, similarly, cardinal number of a finite set. What does it mean? Cardinal number means if you count the number of elements in the set, that is nothing but the cardinal number. In the above definition, the cardinal number or order of a finite set. Order of a finite set is denoted by n of a or O of a. So if you take a set like this, if a is equal to 1, 2, 3, 5, 6, then you can write it as n of a is equal to order of a is equal to 3. This is what you have to understand. If I take another set, which is A, B, C, D, E, F, G, for example. How many elements are there in this one? 7 are there. Correct, no? It can also be written as O of A, order of A. Okay, so this is called the cardinal number. Cardinal number gives you the number of elements present in the set. Next, infinite set. Infinite set, just now we have seen, if the elements are not countable, it is said to be an infinite set. A set whose elements cannot be listed by the natural numbers. 1, 2, 3, 4, so on, n for any natural number, n is called an infinite set. Now, this is what I'd like to insist upon. What are the equivalent sets? Equivalent set means if the order of two sets or the cardinal number of two sets is same, n of A is equal to n of B, then they are said to be equivalent set. For example, A is equal to 1, 3, 5, 7. B is equal to 10, 12, 14, 16. Number of elements of A is 4. Number of elements of B are 4. So O of A is equal to O of B is equal to 4. These are said to be equivalent sets. Equivalent sets. Now, what makes the difference between equivalent set and equal sets? Important, please. Important. So that is equal sets means the number of elements, the cardinal number must be same, and as well the elements must also be same. Two sets A and B are said to be equal if and only if every element of A is an element of B, and also every element of B is an element of A. We write A is equal to B if the sets A and B are equal, and A is not equal to B if the sets A and B are not equal. Symbolically, that equality, whatever we use for real number system is used. A is equal to B. If X belongs to A, if and only if. We read it as if and only if, or implies and implied by. X belongs to A, implies and implied by X belongs to B. X belongs to A, implies and implied by X belongs to B. This is what you have to understand. So what makes the difference between equivalent set and equal set? Equivalent sets will have only the number of elements in each set are equal. But equal set, besides equivalent, each element must be same. Then only we can call it as the equal sets. So if you say A is equal to 2, 3, 5, 6, B is equal to 6, 5, 3, 2, then A is equal to B or not, then A is equal to B or not. Each element of A is an element of B and vice versa. This is not equal because 2, 3, 5, 6 are there. Yes, these are equal. These are equal. Correct or not? 2 is there, 3 is there, 5 is there, 6 is there. Then we can say it as A is equal to B. So every equal set is an equivalent set, but every equivalent set need not be equal set. Do you understand what I'm saying? I repeat.
Yes, sir.
Every equal set is an equivalent set, but every equivalent set need not be equal set. Chaitanya.
Yes, sir. Yes, sir.
That's what he gave. Equal sets are always equivalent, but equivalent sets need not be equal sets. Universal set, in the name itself, you have the meaning of it. A set that contains all sets in a given context is called the universal set. What does it mean? If I am talking about the state capitals of India, if I am talking about all the state capitals of India, then our universal set is India. Our universal set is India. Now, if I am talking about all the country capitals of the world, then universal set is the world. Okay, so that universal set changes from the context to context, which consists of all the elements, or all the sets that are under discussion. So a set containing of all possible elements which occur in the discussion is called the universal set and is denoted by U. Thus, in any particular discussion, no element can exist out of the universal set. This is what you have to understand. No element can exist out of universal set. It should be noted that universal set is not unique. It may differ in problem to problem. That is, according to the context, universal set differs. Okay. Now, power set, before going to this, let us finish that exercise and let us come back to this. Yeah, Maurya. First one, please.
Sir. Which of the following are examples of null set? Set of odd natural numbers divisible by 2. So this is a null set. Set of even prime numbers. This is not a null set. 2 is there. X is to x such that x is a natural number, comma x greater than 5 and x no x less than 5 and x greater than 7.
You are getting confused. I have to give imposition for you. This is less than, and this is greater than. Okay, now read it again.
X is such that x is a natural number, x less than 5 and x greater than 7. So this is null set.
Good. Next.
Y is to y, y such that y is a point common to any two parallel lines. So even this is a null set, sir.
Yeah, Chaitu, second one.
Yes, sir. Which of the following sets are finite or infinite? The set of months of a year is a finite set. The set of, 1, 2, 3, and so on is an infinite set of natural numbers. And the third one is a finite set. The fourth one is an infinite set. The fifth one is a finite set.
Yeah, Maurya, third one.
State whether each of the following set is finite or infinite. The set of lines which are parallel to x-axis. So there are infinite lines parallel to x-axis. Set of letters in the English alphabet, it's finite. Set of numbers which are multiple of 5 is also infinite. So
Good. Let us see next one. Come on, finish up this fourth and fifth.
set of animals living on Earth, infinite, sir. The set of circles passing through the origin 0, 0 is not infinite, sir. It's finite. Set of circles passing through origin. So we can only draw one circle passing through.
Infinite only.
No, infinite.
Yeah, fourth one. Chetu.
Yes, sir. In the following, state whether A equal to B or not. In the first one, they are equal, sir. In the second one, they are not equal. In the third one, they are equal. And in the fourth one, they are equal.
Let's think. See again. Fourth one.
Yes, sir. No, sir. No, sir. It is not equal.
The fifth one, Maurya.
Are the following set a pair of sets equal? Give reasons. A 2, 3, B x is x such that x is a solution of x square plus 5x plus 6 equals 0. We have to solve this, right?
Yeah, I'm solving it for you. The factors are x plus 2 into x plus
X plus 2 and x plus 3.
is equal to 0. So x is equal to
X
minus.
is equal to minus 2 and minus 3. So it's not equal, sir.
Come on, tell me next.
X is to x is a letter in the word follow. So F, O, L, and W. B, Y is to Y is a letter in the word wolf. So both are equal.
You are finishing that sixth also.
Yes, sir. From the sets given below, select equal sets. A equals 2, 4, 8, 12. Sir, A. Oh, sir, A and A doesn't have an equals. So Sir, B and what? Sir, E and G go together.
Yeah,
That
even Chetu, you can also try. Both of you answer.
Yes, sir.
and
B
B and D go together, sir.
B and
D.
D.
that's right.
That's also.
Only B and D anymore.
And E and G.
Okay. Any more, Chaitanya?
We don't have any more, sir.
Yeah. That's it.
Yes, sir.
Sir.
Now subsets. Subset in the name itself, we have the meaning of it. Subset. If you are studying in a particular school X, what is your school name, Maurya?
So India International School, sir.
So India International School, if you take, let us take India International School as a set. And let us take your 10th class, your 11th class as a set. And in which section are you in?
11P, sir.
So if you take, this is 11th class set, and if you're in E section, this is E is contained in 11th. This is nothing but E is subset of 11th. And the square brackets represents a universal set. Your India International School. Huh?
Yes, sir.
Your India International School is U, and your 11th class is a set, and E is a subset. Okay. Now, Chaitu, which school are you in?
Nalanda, sir.
So let us take Nalanda is one set. We are listing out all the CBSE schools of the India and Gulf countries. Let us suppose U contains all the schools of all the CBSE 11th and 12th schools, all senior secondary schools of CBSE in Gulf countries and as well in India. Then Nalanda is one of them. And in Nalanda, if you, this is India International, and this is the 11th class. If you take all different classes of Nalanda school, in that one, yours is a subset. This is 11th. 11th. So subset means it is the set which is contained in another set, which is contained in another set. It's simply the subset. Okay. So if I write A subset of B, then A is subset of B. You have to read like this. A is subset of B. That means A is contained in B. A is contained in B, and B is called the superset. B is called the superset. Understand that? Okay. So it's very simple. Let us go to the definition once. Consider the set X is equal to set of all students in your school. Y is equal to set of all students in your class. We know that every student of Y is also an element of X. We say that Y is a subset of X. The fact that Y is subset of X is expressed in symbols. Y is subset of X. The symbol subset. This is the symbol for subset, please. Symbol for subset is this. Stands for is a subset of or is contained in. Okay. Just now I explained with examples, and I'm not going to extend it. A set A is said to be a subset of a set B if every element of A is also an element of B. You understand like this. That will be more better. In other words, A is subset of B. If whenever A belongs to A, then A belongs to B also. it is often convenient to use the symbol implies, which means implies. Using the symbol, we can write the definition of a subset as follows. How to notate, how the subset is denoted, that's what he's saying. This is the point to be noted, and you have to understand this. A is subset of B. If A belongs to, small a belongs to capital A, implies small a belongs to capital B also. Okay, Maurya, can you read this?
So the one you in the box.
Yeah, not only that, the passage below it, the paragraph below it.
All right, sir. A is a subset of B if a small letter a belongs to A, and small letter a belongs to B. That is all number of implies.
Yeah.
We read the above statement as A is a subset of B if A is an element of A, implies that A is also an element of B. If A is not a subset of B, we write A is not a subset of B.
That's it. Not means generally you might have observed by now. Not is denoted with a line across it. Belongs to like this. Does not belongs to like this. Okay. Okay. Similarly, subset like this. Is not subset like this. Okay. Just with a cross. Now every set is subset to itself. Every set is subset to itself. That is understood. That is understandable. I need not have to explain more about that. It follows from the above definition. Every set is a subset of itself. That is, A is subset of A. Since the empty set phi has no elements, we agree to say that phi is a subset of every set. We now consider some examples. Now, one more thing he is not mentioned. We have to see whether he has mentioned later or not. Now, there are two types of denoting this. If I write A is subset of B now, B is said to be superset and A is a subset of B. If I write like this, it can be written like this also. A is subset of B. You may say that A and B may be equal also in this case. Equality is also shown. There are two symbols here. It is called proper subset. A is called proper subset. There is no question of becoming these two equal, but in this case we cannot say this as proper. Sometimes it may be equal also. A is equal to B also. Okay, so this is called proper subset, and if they are equal, that is said to be improper subset. So proper subset will not contain this equality symbol. Understand that? Okay. Now the set Q of rational numbers. The set Q of rational numbers is a subset of the set R of real numbers, and we write Q is subset of R. Q is subset of R. Okay, like that you can understand that. If you take the fourth one, A is equal to ovals A, I, O, U, and B is equal to A, B, C, D, then A is not a subset of B. Also, B is not a subset of A. Okay, let's move to the questions. If it is given subsets of real numbers, intervals, this is important. This is important. This you will get frequently. This to be understood thoroughly, please. Thoroughly. Yeah, it is clearly given. Clearly given. So yeah, if it is given like this in the small bracket, small open A comma B open, it is to be read as open A comma B open means in this interval all values will be taken between A and B, but not A and B. It is open. Just see. Open means hollow bracket, hollow points. This hollow points means this won't take the values A and B, but it takes all the values between A and B. And it is solid point. Solid points. It is to be read as closed A comma B closed. I repeat, closed A comma B closed. How is it to be read? It is open A comma B open. Open A comma B open. Closed A comma B closed means It accepts every value lying between A and B, and it even takes A and B also. Even it takes A and B also. Next, closed A comma B open. Closed A comma B open. That means you have to understand that A is taken and all the values lying between A and B are taken, but B not taken. So you understand the symbol, this is open and this is closed. This is open. This is closed. Closed means that is accepted, that value accepted. So you can read it as closed A comma B open. And Chetu, can you read this and tell me the meaning of it?
Yes, sir. Opened A, B closed. So it means that A is included and B is not included, and everything between A and B is also included in the set.
Repeat.
I'm sorry, sir.
Repeat.
Yes, sir. It is an opened. I'm sorry, sir. Opened. I don't know. I forgot how to read.
Open A, simple, open A.
Open A and B closed. So it includes all the set. It includes A and it does not include B, and it also includes
No.
all the.
You said you're saying the same. Open means it won't take that value. Closed means closed. No, it accepts that value. So
Yes,
it is A not taken, and all the values lying between A and B taken, and B taken. Okay. If I write like this, you'll better understand. Just listen carefully. Both of you, Maurya. I'm writing that now. Just check it out.
Yes, sir.
A less than X less than B. A less than or equal to X less than or equal to B. A less than or equal to X less than B. A less than X or less than or equal to B. This is what you have to understand. Now it is clear. Just see. Both of you tell me whether it is clear or not.
yes,
Yes,
sir.
sir.
Wherever equality is there, it accepts. Wherever equality is not there, it is open. It is open. It is closed. It is closed. It is open. Both are closed and both are open. Like this it is. These are the intervals notation we use in the problems. Power set is to be explained properly. Power set. So let me start with this. Power set I'll explain tomorrow. And what time is it comfortable, Maurya? Tomorrow?
So anytime after 2:30 in Indian time.
2:30 in Indian time. Okay, your classes are getting finished by 12 o'clock then tomorrow?
No, sir. 1. Oh wait, yeah. 3:30 India time.
3:30. We'll give the same time then 4 to 5. What do you say, Chetu?
Yes, sir.
We'll meet again between 4 and 5. And the wallpaper is there now for this group, Chetu.
I'm sorry, sir. Can you
So
repeat?
That profile picture
Yes, sir.
for that one, group symbol contains the passcode and the ID.
Yes, sir. I saw it.
The same.
Yes, sir.
Generally, sometimes Zoom is not accepting unless it is reinstalled, updated. That
Yes,
is
sir. I actually joined from the website. I reinstalled and I couldn't join the class.
now try it by reinstalling the app, then you'll get it, no problem.
Yes,
Once if
sir.
it is done, no, regularly it happens, no problem.
Yes, sir.
Okay, see you both in the next session. Bye bye.
Bye,
okay,
sir. Thank
sir.